All right, so let's begin. This session is Going Social with the YouTube APIs. I am Jeff Fisher, and this is Jochen Hartmann. I'll be presenting today. If you can read this way in the back, we do have a board you can post questions to. It's tinyurl.com/io-social-YouTube. So while you're pulling that up, I have to continue this. So last year I made this big stink about what the t-shirts meant, and I pointed out how they were ASCII characters for Google I/O. And of course it turned out that they didn't actually say Google I/O, they said Google KO because one of the dots was the wrong kind. So that's the joke, if you don't know, for why this guy has a spray can on the back, and really faintly at the end here you can see KO kind of sprayed on. So if you haven't caught that yet, that's a continuation of my disaster last year of explaining the shirt that was wrong. Okay, so we all have Google Moderator up and running. Okay, good. You will be able to also ask questions in person, but if you're shy or just don't like to talk to me. So we're going to do a little polling of the audience to make sure you're not asleep. I know it's the second day. I'm pretty tired too. So who here has used YouTube before? Okay, so you're not all asleep. That's good. So who here has used the YouTube API before? Good number. Okay, so how many of you have noticed on YouTube that we have these social events, like what your friends are doing or what you're doing, like on your channel page? Anyone seen that little box? Okay. So now we're going to merge those two, and this is very rare. Has anyone here actually gotten those events through our API yet? Good, you're in the right talk. That's what we're going to talk about. So so this talk is about how we're going to get these social events and make them available to you as a developer. And we're going to do this mostly by going through examples, because examples are better than just a bunch of slides about XML. And we're going to have one example first that's just really basic. Okay, I'm going to retrieve activity for a user. I'm going to retrieve their friend's activity, and I'm going to retrieve some information about that. And that's all done in PHP. We also have a second sample that's a little more involved, which also has a PHP component to display information. But this example goes a little bit above and beyond just a simple one-user use case, and it lets you figure out how you can build an app that will actually scale to support a site with like millions of users that you want to keep track of all of their YouTube activity on. And that one's going to have a Java component to help us with the whole scaling and speed thing. Okay. So why do you care about YouTube activity? Why are you here? Well, there's some neat things you can do with it. For example, you can bring these events into existing social networks as status updates or stories or what have you. You can bring this information into social applications, devices, gadgets, all that good stuff. So it's exposing it to your users in another way. There's lots of aggregators out there. It's very popular right now. You can also use it, obviously, to create a better YouTube search experience. So if you know that my friend rated something 5 stars, then perhaps you want to recommend that video to me more highly in the search results or highlight that somehow, because that would probably be more interesting to me than just a normal video if someone I knew liked it. And then, of course, you can also educate your app about what a user is doing on site. So if you have a really awesome, say, Android or iPhone app, you don't really know what a user does on YouTube when they're not using your app. So how can you train that app to respond to those events? Well, that's what these activity feeds are good for. So for example, I just rated this 5 stars again. You go back to that example. And I'm out and about, and I have my little Android device, and I'm not lying, I actually do have one. It would be really useful if I had this really awesome app for it that already integrates with YouTube. If it was like, hey, here's all the things you recently rated highly or that you favorited. I mean, now I guess with Cupcake, you can get your favorites on the YouTube app. But, I'm just saying, like, you can actually learn from what a user is doing and provide useful suggestions in your app, which is cool. Okay, so now I mentioned this is, or maybe I didn't quite mention it, but we're using this API. It's called the YouTube Data API, and it's very similar to our other Google Data APIs, if you're familiar with them. Speaking of which, how many people have used one of our data APIs, spreadsheets? Okay, all the other ones. Okay, so you're familiar. Okay. So this is based on the Atom Publishing Protocol, which, if you're not familiar with what that is, it's a lot of XML. So our API is a lot of XML. We're working to make that better, particularly with doing more things with JSON. There was a talk the first day, so if you didn't see that, you already missed it. But we are going that direction, so it's going to be less work in the future. But for right now, it's XML. And we're not going to go into too much detail about the API, but you should know that it's versioned. So 2 is greater than 1, yeah. Version 2 is the current version and has all sorts of goodies like GeoSearch and all this activity stuff we're talking about today. And version 1 doesn't have them, so don't use it. The API basically allows us to look at metadata of all these different things on YouTube, users, channels, videos, comments, what have you. And it also allows us to programmatically create and manage them. So you can create a playlist for a user. You can favorite a video on behalf of a user. You can also, of course, upload a video, because what would a YouTube API be if it didn't upload videos? And then, of course, you also probably don't want to deal with XML any more than I want to deal with XML. So we have a number of client libraries in your favorite languages. I actually have a really lightweight thing I wrote for Ruby, if you're a Rubyist out there. So you don't have to deal with the XML directly, usually. But like I said, this isn't a talk about the YouTube API in general. That was last year. It's on YouTube if you want to watch it. But this is a talk about activity feeds and what we've done recently. So activity feeds on YouTube, if you've been to your channel page, you might have seen this little box, and it has stuff that you've recently done. There's also a similar box on the home page you can configure of your friend activity, so all your friends, what they do. And yes, there is a giant privacy settings link, maybe not super giant, but it's there. It's boxed in red for you. So if you think all this stuff sounds scary, you don't want applications learning about your activity on YouTube, you can go in there and uncheck all this, and none of what I say in this talk will apply to your user account anymore. So there it is. To give an actual demo of this, and to prove that it works, it's not just screenshots, I'm going to have Jochen navigate me through here. So here we have spaces. So here we have recent activity box down there, like I promised. And now why don't you go do something like go favorite a video.
All right.
Find something clever. I don't know.
See what he has here.
Oh, that's kind of interesting. That's not a very good thumbnail, is it? It's catching people. Okay.
So there it is.
So we have a favorite. So if we go back to just click on like IO demo, the username, channel page. So look, it actually showed up right away. Yay. Okay. So this social stuff actually works. So now we're going to show you a demo we built that uses our API to fetch this self-same information. So if you log in, we do this with auth-sub. It's all documented. Basically, we redirect to YouTube, and we have a little crypto key to make sure that we're from the right domain name. And we get back here again, and now we have access to the user's feeds. And as you can see, this is the same information that was just in that box, but it's on our little site. And you can do the embedded player and whatnot. And also, of course, you can do friend activity if you want to click on that. And you can see what your friends are doing. But these, of course, have to be people that you've actually friended on YouTube. We also allow you to search for arbitrary users. Okay, so the question was, can you search for Gmail contacts? And the answer is no, because unfortunately, you can link a Google account, a Gmail account, to a YouTube profile, and there might be some crazy auto-suggest stuff where you can figure out their YouTube accounts through that, but you actually, as of right now, still have to friend them explicitly on YouTube. Like, we don't automatically share your stuff unless you go to YouTube and actually approve. Mm-hmm. Yeah. So gentleman was just saying that in Open Social there's some useful stuff about finding the most contacted and whatnot. So YouTube has a lot to work on in that aspect. We can talk more about that later as far as how we're trying to merge the idea of YouTube accounts and Google accounts and make this actually useful to you and not have like a million different friends lists. That's a little bit outside the scope of activities right now, but that's a very good point. And part of what we're going to talk about here is how if you are some other network that already has contacts, so if you're in MySpace, per se, you already have a friend graph, and how can you use that friend graph and leverage that against YouTube without actually having some deeper integration on YouTube's part. So we showed you the demos. So these feeds work. And this is just a URL you retrieve. It's just YouTube feeds, API uses. This is documented. I don't expect you to memorize this right now. So we just retrieve those events from the API, just like how the box retrieves them from our database. And there's a very similar URL for friend activity, and we just retrieve your friend's activity. But as was mentioned, right now this is limited to YouTube friends, which isn't the most useful thing in the world because not everyone remembers to friend people on YouTube if they're already friended on Google Contact or Google Talk or Orchid or High5 or MySpace or whatnot. So yeah, without getting ahead of ourselves, the activities that we currently expose are usually related around videos, so like the video rated, shared, favorited events. We also have some user activities, so if you add a friend, we'll tell you the feed will reflect that this user just added a friend. Similarly, if they added a user subscription. But what does it look like? What are you actually seeing in this XML that I promised you? Well, there's an entry, because that's how AtomPub works. Every item is its own entry. And each of them has this ID, which is just this big, long string. Don't put too much thought into this, but it will be unique, and that's what's important. We also have updated element, which will tell you when this event took place, so it's useful for sorting and organizing. We have a category, which will tell you what type of event it is. So this is a user upload, a video upload to a user channel. And we have a short descriptive text in the title that you can just display verbatim to the user to tell them what the event was. In this case, Google Developers has uploaded a video. And then we have the YouTube username and its own element, so you don't have to regex that out. And of course, because it was a video upload, we'll give you the video ID. Now, we're only giving you the video ID for this video. We're not giving you the video title, its rating, its comments, all that stuff, because we don't really want to pollute this user feed, because we're going to talk about in a little bit will be how you can intelligently cache that information. And that's all we have. So there's a little bit more information in, for example, the video rating event. We will actually tell you what rating the user gave that video. But we still aren't going to tell you any other video metadata about it. And of course, if it's a user event, we will tell you the YouTube username of the user they interacted with. Okay, so that's what this is, just inside of a giant XML feed. Do not try to read this. I'm just showing you what I saved you from having to try to digest. So that was a lot of XML, and so here's some kittens, because I don't like XML, but I do like kittens. And so clear your minds of all that XML. We won't talk about it too much anymore. So how did our sample work? Well, we have a server. It's a slice host server, incidentally. It runs a PHP website, and this PHP website is going to go into the cloud and access the YouTube API and retrieve the activity information. And as it does that, it's going to also, like I said, you're only going to get the video ID back, so it has to make additional calls to the API to populate all the video metadata for each of those videos. And then we store that video metadata in a nice caching system like Memcache, which I heartily recommend to you. It's not just because we hired the guy who wrote it. It's just a really good system, and it's free. So we store the information in Memcache, and then we render all of that to our front end, which is written in jQuery, which is also awesome, by the way. And we just use a compact JSON format that we created on the fly to do that, because there's a lot of information in our XML feeds right now that is usually extraneous to what you want to display on the site. We're working on fixing that in the protocol level, but for right now, you can just kind of dig out what you need and render it yourself. So the things you got to keep in mind here is you want to be smart. You want to request metadata for each of these items you're getting back, because telling me that my friend just favorited video X539760 isn't very useful to me. And you can retrieve all that metadata, fortunately, by the ID, which we do give you. And similarly, you can retrieve all the profile information just by using a YouTube username. And so as you're doing this, you can request only what you need as you need it, which sort of leads us into the next part, which is be scalable. So if you have 1,000 activity items, but no one's looking at them because you just pulled them, but there's no users looking at that yet, you don't really need to retrieve that metadata because no one's going to look at it. And why incur the penalty of an HTTP request if you don't have to? So what you should do is when you do make requests for video metadata is you cache that somewhere, usually 1 to 2 hours is safe. And you're trading freshness here for basically speed and scale. And obviously, if you've been to other talks, especially App Engine, they'll tell you that hitting a local cache is a lot cheaper than making an external HTTP request to our API. And once again, I do recommend you use Memcache to do this. And the last caveat I really want to mention with this sample is you want to be robust. So there's a lot of different errors that can happen whenever you're doing network programming. The connection get interrupted, and even like our servers can temporarily go down or lose your session or whatever. So just be graceful when service errors happen through the API for whatever reason, and provide nice messages to your users. I mean, this is just kind of a general good programming practice, but we've run into some problems like with people not displaying useful information, because our API is pretty decent in that, like, for example, if YouTube's in read-only mode, that happens a little bit often for my taste, you can detect that in the API because we'll give you back an error message that actually says pretty much, YouTube is in read-only mode, you cannot upload right now, but you can still read. And so you can display something useful to the user if they're trying to upload a video and didn't work, for example. But to talk about the actual PHP website itself, I'm going to invite Jochen up here since he wrote a lot of it. He does a lot of work with our PHP client library, so he's much more familiar.
So I wanted to start with just a general question on how many of you have actually used one of our client libraries before? Okay, only a few people. Okay, so I'm going to go into a little bit about how our client libraries work and why we encourage you to use them as well. But for this application, the PHP website is a very simple component. I'm going to talk about this basic front end twice. So this is the first time I'm presenting you with the overall structure of how we design this, and then we're going to reuse the same front end in the more complex application, and at which point I'll just skip all the basics because you should already know them. In general, the kinds of things that we need to do is we need to create sort of a service object that we use to connect to YouTube. You'll notice that the word Zen there, that's because our PHP client library is part of the Zen framework. I don't know how many people are familiar with the Zen framework, but it's available also as a separate component, a separate download, so you don't need to download the entire framework. And this is a common use case for all the other client libraries. You create some type of service object and use that to interact with our APIs. The other function, obviously, is we want to fetch the activity for a user or for their friends. We fetch metadata from the YouTube API, so that was in the previous diagram. We're actually making two requests because we don't have the metadata yet. We just have a video ID in the event that Jeff showed. So we need to go out again and get the metadata for the API for the video. We create our own JSON feeds inside the application just for performance, and also because we're using a jQuery front end, so it's very easy to work with JSON and jQuery, obviously, and we're only interested in displaying specific information, not everything about the video. And then, we use memcache, so I'm not going to explain that too well, but memcache is very easy to use in PHP. You just get stuff out and set things in, very simple. So what we're doing here is I'm going to explain how you would use the YouTube service object that you need to communicate to the API with. This code is a little bit different because we're actually using authentication here. Because we need to get a user's friend activity, you need to make an authenticated request. So this is why we're using the Zen GData authsub object here. Authsub, how many of you are familiar with authsub authentication? Okay, only a few. So I'll explain that a little bit. So in general, for our APIs, we have two forms of authentication. There's a client login-based authentication, which would be for desktop apps or devices. And that's just simply sending username and password to our API and getting back a string, and then you use that in the header and you're authenticated. Authsub is different. It's more of a sort of a token or proxy-based authentication where your application basically sends a user over to YouTube, which is what you've seen when we demoed this. They sign in on YouTube, and then they get sent back to your application with a token, and you store that token and make authenticated requests basically on their behalf. So what we're doing here in this line of code is we're basically creating an HTTP client, which is going to handle our communications on the HTTP level, and we're passing in just the session token that we've received after the user has signed into YouTube. And then we just set the client in the constructor of the Zen GData YouTube object, and now we're basically authenticated. You'll notice here, though, that there's some other parameters that are actually very important for using the YouTube API. So in the second line there, you see client ID and developer key. These are very important. You need to use a client ID and a developer key for any authenticated requests that you're making to YouTube. Of course, if you're just doing a read operation on YouTube, so you just want to get a feed or something that doesn't require any authentication, you don't have to worry about any of this stuff, you would just use the second line here. So you just create a news ngdata YouTube object, and you go from there. And lastly, as Jeff mentioned earlier, we have 2 versions of the API. So we want to set the version to 2 so that we can access the activity information. Here's a slide that shows how this would work in other client libraries. So like we mentioned, we use PHP because I've written a lot of the extensions, and it's very straightforward for web stuff. But if you prefer Java, .NET, Python, Objective-C, I don't have on here, but it's generally the same. So you create a kind of a service object, and then you communicate to our APIs with that. And all these client libraries work for other APIs as well, so it's all very similar. So you can make requests to Calendar, YouTube, etc. Getting activity out is actually very simple. It's just this method, get activity for user, and you just pass in the username that you want activity for. We support up to 20 usernames, so you can kind of get aggregated activity. What you get back is an activity feed, and this is another characteristic of our client libraries, is that they abstract a lot of the XML and transform it into objects for you. So that's a lot easier to use a lot of times. So in this case, we're getting an activity feed. That feed is going to have entries. Entries are going to have properties. So it mirrors the XML structure exactly. To get friend activities, you just use the get friend activity for current user method. The reason why there's no parameter here is because you can only use this when you're authenticated. And at this point, the client library will know your user, so you don't have to pass in anything. It'll just get all your friends' activities. Now, getting video metadata is kind of a multi-step process here because, like Jeff mentioned earlier, we're trying to be robust. So we want to account for errors, right? Because you could be fetching video information the same second that somebody deletes the video on YouTube. So you want to be able to account for these kind of things. So we're getting our service. I've abstracted this in the application in just a simple method. And by the way, all the source code for this is available. So if you want to look at it later in detail, we'll show you the link. So then what we're doing is we're just using the get video entry method here, passing in just the string that represents the video ID. And this obviously was in the entry event. And the next thing we're doing is, like Jeff mentioned, we're creating our own JSON here. So this is very simple to do in PHP. You just create basically an empty array, and then you use the JSON encode function. So in this array, I've skipped a bunch of the code, but we're just actually getting the relevant information that we care about. So we get the ID, we get the title, and so on. All the stuff we want to display in our front end. All of these methods are basically get video X. So there's a ton of method inside the video entry object that you can use to access the metadata, whether a video is private, all this kind of stuff. And then, so I'm skipping a little bit of stuff, and then, of course, we want to handle any kind of exceptions that may happen. And this is how you would do this with our PHP client library. So you want to catch an HTTP exception, get the response, and then get the status, and that'll actually tell you the actual HTTP error message that, actually that's the error code, I'm sorry. You can also get the string of the message. And then we check on that code if it's a 500 error or if, any other error, we just say video is not available. The reason why we're doing this is because we want to pass into our JSON feed some kind of a string that we can interpret in jQuery so we can print out a useful error message here instead of just sort of an empty object. And that's basically it for how this application works. The code is on googlecodesamples.com. You can just go to the PHP tab and find it there. So next, we're going to go into part 2, talk about scaling. So I'll hand it over to Jeff.
Okay, so we've been through the basics of how you could build this app, and certainly it's not too hard with our client library. But what happens if you have 1 million users? Or what happens if you have your own friend graph? Or terror of terrors, what happens if you have 1 million users and your own friend graph? Well, are you out of luck? Well, no. So we do actually have a solution for this that we are announcing today, and I don't think it's even in the documentation yet. So, and that's SUP. And what's SUP? Well, not much. I know. But what is SUP? Okay, so it's the Simple Update Protocol, and the Simple Update Protocol is a simple and compact ping feed that web services can produce in order to alert the consumers of their feeds when a feed has been updated. So this is a project on Google Code Hosting, and it's actually done by the friend feed guys who used to be Googlers. So, and also, I should mention that friend feed was able to integrate this new thing that we just launched like yesterday. So they're pretty fast too, or it's just that easy. So anyway, SUP is solving this problem. So when you have 1 million users, how do you get their activity? Well, you could poll each of their individual 1 million activity feeds every few minutes and see if they've done anything. But that's 1 million HTTP requests, and odds are that most of your users won't have done anything, especially at like 5 a.m. Well, maybe at 5 a.m. But so wouldn't it be nice if we had one simple little JSON feed that just contained a big list of all the users that actually have done something in the last 5 minutes? Well, that's exactly what SUP is. So if you go ahead and retrieve our SUP feed, which is just gdata.youtube.com/sup, S-U-P, you get back this thing that's, like I said, JSON, and it's really simple in its construction. So we have an updated time, and that's just going to tell you when the feed was last refreshed, so you can use that to check if it's changed since the last time you polled it. We have a since time, and this identifies when the activity conveyed in this SUP feed began, so when the beginning of the window that this SUP feed is for. We have a period, which is in seconds, so 300 seconds is 5 minutes, which is the default. Then we have other periods and links to those. But the most important thing is we have updates. So updates is a tuple here of 2 different hash codes. The second, which is the time code hash, which you can just ignore. It's not really useful. But the first one is the user hash. And so the idea here is that if I know the user hash for the 1 million users that I am interested in, I can hunt through this SUP feed, see if any of those 1 million hashes are actually in here, and if so, I can poll for the activity feed for those users. So pretty straightforward, but there's an obvious problem here, which is how do I know what users these hash codes correspond to? And to do that, you just actually retrieve the activity feed for a specific user. And if you look in the activity feed, we have just a link element that has this link that points to our SUP feed, and inside of the anchor part of that URL is the hash code. So the flow here is that someone will go to your site, and they will authorize you to use their YouTube account or otherwise indicate what their user account is on YouTube. And then you can pull their activity feed, which will give you a chance to pre-populate all activities they have done in the past. And at the same time, you can grab their SUP hash, and now you can start monitoring the SUP feed whenever they have updates. So pretty straightforward. So to demonstrate that this, again, actually works, we built another activity viewer called the Uber activity viewer that is going to do the same process and retrieve user activity. So here I can, I suppose, just show it. What could go wrong? OK, so here we have a really simple website that just shows you all the activity for users that have joined the website. Sort of a friend connect idea, right? So you just go in to add yourself, you allow access, and voila, you get added to this background process that fetches information from YouTube. So yeah, as you can see here, the video we favorited at the beginning has already showed up, although the thumbnail doesn't seem to be quite displaying, probably because it's not embeddable. But yeah, so the activity that we added earlier actually just showed up already since our demo user was already a member of the site. So that's kind of cool. So here we're polling for users, and we're not actually retrieving their activity feeds until we see them in the SUP feed. And you can try it yourself at just googlecodesamples.com/uberviewer. So if you want to add yourself, and we can go back to that later and prove to you that this actually does work. Although you will have to, after you add yourself, do something on YouTube to show up on the SUP feed. So how is this sample built? Well, again, we have your server somewhere in the cloud. And now, instead of just a PHP website, which we also have, we have a Java daemon, which is going to handle all of this SUP business that we talked about. We also have a MySQL database that allow these two to have some sort of shared storage. And we have Memcache, again, to store video metadata for us. So the Java daemon goes out into the cloud, fetches our SUP file from YouTube, parses that out, and figures out what YouTube users were interested in, and then retrieves those users' activity from the YouTube API, and then puts all that activity into our database. So pretty straightforward so far. The PHP website then just goes into the database to fetch recent activity for the site, goes to the YouTube API to fetch additional metadata about all the videos and whatnot that have had activity, and then stores that metadata in Memcache, and once again, has a nice little JSON interface to our user interface. So pretty straightforward. And now we're going to go into each of the parts, first the Java daemon and then the PHP website. So why do we pick Java? Well, because it's multi-threaded. And someone already criticized me, why don't you use Python? Well, I could have used Python, but our client library just happens to be a little more friendly in Java. So, hey, I use Java. So we have a couple different threads here that are going to handle these different parts. And the idea here of why we need threads is because, like I said, if we have 1 million users and we're trying to get all of this activity processed in a 5-minute window, you probably want to be doing this, multiple users at a time and not serially retrieving each. Because, even though only 20,000 of those users may have activity, 20,000 requests is still a lot to do in 5 minutes. So here's a basic diagram, once again, just of, we have the sup fetcher thread that's going to actually retrieve the sup file and parse it for us. And now we have this synchronized queue that is going to get appended to with the username of what user's activity needs to be updated. And then we have these activity fetcher threads, which you can configure how many you need, which are just going to grab out of that queue and actually pull down the activity for each of those users, while acquiring a lock on them so they don't fight over the same user. And then, so they just go up to the YouTube API to fetch the activity, put that in the database, and we're done, basically, because all the rest is handled by the PHP website, which is, again, very similar to the PHP website we saw before. So what do we do to start threads? If you're new to Java threading, you pass an object of your creation that implements runnable to the thread constructor, and you say start. Pretty simple, and you do that again in a loop for all of your activity fetcher threads. Oh, and all of this code is also open source, although we haven't quite posted it just because of all the hecticness on I/O. But you can bother us afterwards, and we're going to get that posted. So don't worry about copying this all down now. So to close threads, again, pretty simple. If you remember your operating systems class however many years ago, you interrupt them, and then you join them back to the parent process. Okay, so we have some things that we're using to share state. We have this config data object, which is just a read-only object that parses some configuration files for us that provides like the developer key that we're using and the database passwords, that sort of stuff. But the interesting stuff is we have some thread-safe objects that Java provides us, like that blocking queue that I mentioned earlier, and this concurrent map of user locks. So these two things are going to let us have communication between the threads in a safe manner so they don't stomp on each other. Okay, so the main thread is going to be really simple. It reads the configuration files into that object that I showed earlier. It sets up some logging with log4j, which is an awesome logging system for Java. Initializes the other threads, and then it listens on a shutdown port before rejoining them. So while practicing this, someone who knows Java a lot better than me criticized me for not using the shutdown API in Java, and I couldn't get it to work with Eclipse. It was a lot of hassle, and Control-C didn't always do what I thought it would. So I used this, and this is a nice hack. You listen on a local port, and when something tries to make a connection to that port, this accept call will finally return, and then you quit. So you can just telnet to your server, make a connection, and you're done. So close your daemon however you're comfortable with, but this is how I did it for the sample, so it's easy. Okay, so the sup fetcher thread, what does the code look like there? Well, it's going to have to retrieve users from our database, and kind of an implicit part of this is when the website adds you, it actually does that step of adding your token to the database for our Java daemon. We could have done it in the Java daemon, but we're lazy. So we have the users now, and we retrieve the sup feed. For each of the user hashes we find, we add their username to a queue, and oh yeah, that's it, right? Because what else do we have to do? The activity fetcher threads take care of the rest. So, okay, what does the code look like? So this is a really hacky way of scheduling stuff in Java. I basically compare a date object to see if it's after the time we're supposed to run, and if so, we do all our magic, and if not, we sleep. If you're really crazy into Java threading, you can use something called executors, and you can actually schedule threads to run at a certain interval. But this is really easy for samples, so I did that. You're noticing a theme here. I didn't take the most complex route in a lot of these because I wanted my sample code to be relatively legible. So to update the time, you just add so many seconds to a calendar object, and Java's nice like that. What's really important is what we're doing with the API. So we get back this user map from the database. It's just using JDBC. and you get back the sup feed data that's parsing out those user hashes and time hashes from the sup feed. And then we do a little Java magic here. It's kind of a nice one-liner to get rid of all the keys in this user set we got back that aren't in the sup feed. And then we're left with a nice map of all the usernames that we're interested in, which we can then append to the queue. So we go through the sup feed, we parse it out, figure out the ones we're interested in, and then we add those ones to the queue. Now we go into the activity threads. So they're going to grab each of these usernames off the queue one at a time, acquire a lock on that username, retrieve the activity feed for that user, and then add their activity, of course, to the database, ignoring duplicates, which is where that ID element that I mentioned earlier comes into play. And then we're going to release the lock and go again, get another username off the queue. So getting something off the queue, really easy, and this blocks, so you don't have to worry about sleeping here, even though you might have to worry about sleeping in this session. No, I'm just kidding. So we also create some sort of mutex lock so that each of these threads is only going to retrieve one username at a time, so two threads aren't retrieving the same activity feed, including our database. We get the lock, we acquire it, we get some metadata about the user. So this is kind of an aside, but it's an important aside. So I don't know if you know about e-tags, but they're a caching mechanism used in HTTP to check if you've already retrieved something or not. So this is how we check that we haven't already retrieved this particular activity feed, insofar that it has changed since the last time we pulled it. But we also have the feed updated time, which is useful because when we get the activity feed for the user, we can pass that along, and we can actually filter out all the activities that happened before, since the last time we pulled. So it's just a publish min query parameter. It's, again, in our documentation. So, little efficiencies help you out. And once you have all those activities, you put them in the database, you dig out the metadata you care about, store it. And there's some things to watch out for here. First of all, if the sup feed hasn't been updated, you should actually check that since time and see that it has been refreshed. Again, be robust. If the API returns errors, it shouldn't, but sometimes it happens. Please handle that gracefully. And the database connection might die. So I don't know if any of you here have had a lot of experience with JDBC and MySQL, but it's kind of a pain, yeah. Because the connections will close, especially if you have a long-running daemon process like this after 8 hours, but it's not really closed because there's no intrinsic way in the connector to check if a connection's closed outside of performing a query. So the hack that I used in this, and you're going to probably look down on this, but I actually make a really cheap query on the database before I do my real ones because I didn't want to bother to rewrite some sort of logic where if the query fails, I try it again after recycling the connection. And do what you will. If you use Hibernate and you're have a big beard and you're great at Java, you have connection pooling for you, so you don't have to worry about this. And I'm sure if you have a big website, obviously you have solved the problems of Java and databases already. But that's my experience with this sample. And in the real world, we're not going to build a website that just has all of whoever signs up's activity on the front page from YouTube, because that's kind of silly. It's a great illustrative example, but what can you actually do that's useful with this? Well, obviously, you can have other daemon processes that once you get this data, you can filter it, you can aggregate it, you can sort it into different friend circles and do what you want with it. You can send notifications to users on their devices. And again, like I said, you can learn from user behavior. So if you know what all of your users are doing on YouTube, you can extrapolate some interesting things from that information. So yeah, this is just kind of a really simple sample to show you that you can get this information into a database somewhere, and then you can do whatever you want with it. And what you choose to do with it is up to you. I'm happy to hear what your ideas are after the session. So now, again, talk about the PHP website. We have Jochen back again.
All right, so I'm going to review the same basic front end with a couple little optimizations, and then we'll finish up the talk and open it up to questions after that. So this time, we're basically doing the same things that we did before. So we're getting activities, we're getting metadata, stuff like that, except we're doing the login a little bit differently this time because if you remember, we're still using AUSA, but last time, because we're making authenticated requests for a user's friend activity, we need to have a session token that we can hold on for the entire time that they're using the application, so we can continually make authenticated requests. This time, we really need to authenticate only once to get the hash that is in the subfeed. So the way authsub works is when you authenticate the first time, you get a single use token back. And you can use that exactly one time. Normally, you use it to send another request to get a session token. But this time, we don't really care about a session token, so we actually use the single token to get the hash, and then we don't need it anymore. We write stuff to the database. We're just using the MySQL extension in PHP, very simple. And again, we're working with JSON here, so we're building our own feeds a little bit in PHP because we want to read JSON feeds back as quick as possible and write them and send them to our front end, the jQuery front end. We're doing some paging as well because there's really no end to the amount of activity that could be in this application. So we could have thousands of millions of users, and so we don't want to actually figure out how much stuff we have in our database. So we just use paging in MySQL to just continually give us a set of results until there's nothing left. Again, we're using Memcache for performance, and what we decided to do here is just basically fetch a page of activities from the database and then display it and then write it to Memcache so that when you're paging back and forth, as you're going back, it's going to get faster because you can hit Memcache instead of the database. So the way we're doing authentication here, again, is we're getting the user profile, and what you see here is that I'm passing in the string default. And that's a nice feature that we do in the API. So after a user has completed the authsub process, you don't actually know their username. You know that you have a token for that user, but you don't actually know what their name is. So we need to get their username. And because we don't have it, we can pass in the string default, which will give you the profile, in this case, of the currently authenticated user. So once we have their profile, we can get their username. So this is what we want to write to our database. And then we're making an authenticated request now to that user's events feed. And we're looking for the link that has the updates rel attribute. And then I skipped the PHP part where we're doing a little bit of string hacking, but really we're just stripping off the last anchor tag here. And this is how we're getting the hash. So now we have the two things that we care about, the username and the hash, and we use MySQL to write this to the database using a prepared statement, very simple. To get the activity feed back from the database, what we're doing is we're doing a multi-step process here. So first we're just reading it, passing in an integer for the page that we're currently interested in. Then we're passing that to an add metadata method. Now this method is going to look through that feed, look for the types of activity that can obviously either be video or user-related, and then it makes separate calls to the API. So if it's a user activity, we fetch their full user profile, get all the metadata that we're interested in. Video, we do the same for video. So we add all this back and then just JSON encode it, and now we have our JSON output that the jQuery front end needs. To get the user profile, we're just making a call here to get user profile. And again, we're using a blank PHP array, in this case profile data, to just get the metadata that we're interested in. There's a lot of data, so you can get first name, last name, about me, all this kind of stuff. So we're basically storing everything. What I didn't show on this slide is sometimes, a value could be null. So what we do at the end before we write the final array that we're interested in is we're just looking through this particular array and stripping out anything that's null. For video metadata, it's the same call that you've seen before. So we pass in the video ID, get a video entry back, and write this also to our JSON. The way we're handling paging is, like I said, we memcache each particular page. And then in MySQL, you just use the offset parameter that you can see here. So we're just passing in. So basically what we're doing is we're using this page variable. And if it's not understandable to prevent any hacking, of course this is not a production app, but we initialize it to 1 if we can't understand what it is. And we just multiply it by the number of items per page, which is a configuration variable of how much you want to page at a given time. And then we just pass that to the offset and get our activities. That basically sums up the application. Like Jeff mentioned, we don't have the code published yet, but we can get on that, if you bother us. I wanted to mention that we have office hours starting actually now. They're going to be outside, so you have to walk all the way around the back section, and you'll find us in the corner. We'll be there. We'll have some YouTube API engineers. We'll have our product manager. So any questions you have about YouTube at all, we're happy to help you.
And we're next to the Wave guys, so
Yeah.
if you come to see them, you should at least come to see us too.
Yeah, definitely. Say hi. Okay, so.
Oh yeah.
Right.
So thank you, Flickr, Creative Commons. Oh. Yeah, because I didn't really take a picture of a lion. I'm sorry.
Yeah.
So yeah, now we have Q&A. So if you could go up to the mics, we also have that moderator link that we mentioned earlier.
Something in there.
Has anyone actually posted to this? Oh yeah, we actually have questions. Okay.
Nice.
I thought I was gonna have to write my own. Like, Jeff, why don't you have a haircut? Okay, so let's see. Unless there's anyone. I always prefer a live question. Okay, you're just sitting down. Okay, good. Is it possible to further parse up via parameters to return file contains only? Whoa. That's awesome. You actually put your location down there. Throw east side. Okay. No. So I guess the point of SUP is that we can show you all of the users on YouTube who have activity in 5 minutes, and we don't know which of those people you're interested in. If there was some way for you to register with us, which those users, I mean, we could build something like that, but that sounds like it would just offload all this burden onto our systems, which, is good for you. But it's a little bit harder convincing the systems guys to build it. The idea is that this feed is somewhat large because, there's a lot of YouTube users out there doing stuff. But it's like 700 kilobytes, and it's JSON, so it parses really fast. You could run some benchmarks, but using like the Java stuff that we showed, I was able to parse the file in like no time at all, basically, and hunt through the ones that were interesting. I'm just not sure of a way we could implement that wouldn't basically be you registering each user with us somehow, and just be doing the same thing essentially, just on our servers instead of on yours. Okay, so is there a way to drive users of an application which uploads videos to become friends?
So I guess this is more like you want to look at your friend graph and maybe connect users that are doing similar things. I think, you could do this obviously by just doing some parsing on your end and seeing what users you have that are generally maybe interested in the same video or rate the same videos highly. And you can use client libraries to add context. So, you could make it very easy for a user to just add somebody as their friend or subscribe to a channel.
Right, which you can do through the API. Them. So you can actually issue a friend request through the API.
Yeah.
And we're working on the contact stuff, making that a little more robust too. And like I said, it's still in a little bit of flux because, obviously YouTube and Google accounts didn't used to be the same idea, but, in the future. Okay, so can you choose to avoid showing a video without manually finding? So you don't share ever videos that you're watching. Watching is only if you're part of that experiment with the bar across the bottom where only your friends online right there can see what you're watching. You can share with them only if you turn it on. So the watching a video isn't one of the events. And right now, I think the only granularity you have is you can opt out of particular types of events in our privacy settings. So like, show my video uploads, my recent activity is one checkbox. Show my favorites, or videos I favorite is another checkbox. Videos I rate, you get the idea. I don't think there's a way to explicitly do stuff. So I guess if your question is how can I favorite, some video I don't want my friends knowing I favorited, that's a little tricky. I guess we have to figure that one out.
Yeah.
Any other questions? Live questions? Complaints? Oh, sir.
When you're trying to do the favoriting, and since unless you pull a data in as, say, not as JSON, you pull it as PubSub, could you PubSub it and point it to a static page, and then hit that static site link, and then hit that score as a flat page I can search. So you could basically have Google pointing to a URL, search that, give you analytics, and give you that information without having to go through what's common user. So, just depending on each person, they can have their own unique page. It's like you do that with Gapminder when you do like docs, and you publish it as your URL. You just point a search engine, a custom search engine, and you kind of get it to work that way.
Yeah. You could build really easily something in PHP that just rendered it. Okay, I kind of lied, because we do have a JSON format right now for our API. Like, it's just alt equals JSON. There's also RSS besides Atom. But it's kind of ugly. in my opinion. So if you like JSON and you see this feed, you'd be like, oh. So it's because it's literally a one-to-one translation of the XML. But yeah, like you said, there's nothing that's stopping you from rendering a page per user. Actually, there was a site I remember. This is like a normal user found the site, and all it did was use the API to grab their username and then display some information about them, and then it turned up in a search somehow or something. And they're like, well, how does this person have information about me? And it's like, well, because you have this on your public profile. And
Yeah, but see, if you do it private, you can lock it out. You can log into it. You do point a custom search and custom alerts to it.
yeah,
Literally, when videos pop up like about maybe microphone or whatever, they get an SMS alert saying there's new video here, just like YouTube alerts or something. It's the index. Because they're already there cached by the index. So you can lock it out. So you can custom search it, make it only certain people see it, only certain people that contribute to it. So you can,
right. So and this wasn't on the microphone. So for the audiences at home, gentleman was just saying that obviously you can leverage some of our other Google properties and the properties of Google Search and indexing and alerts to do a lot of this stuff that we talked about for you. Right.
And then you can go to context right away, because you can say share or not share. You can post a calendar.
Right, so you can integrate with contacts and calendar, and it's a much better story. I hope that someday that can just be part of YouTube, and we don't have to try to work around it too hard.
Yeah.
Well, you can log in with your Google account, but it gets tricky because there's all these weird states. There's literally a flow chart that has like 6 states in it. Okay, any other questions, comments? Okay, so we're going to be outside, like we said, like way back in that corner of Moscone, and you can just come ask us, if you were timid, didn't want to get recorded on video or whatever, and we'll tell you about what's wrong with your app or how you should put YouTube into it, whatever. So, thanks for coming.
All right.